Okay, hello everyone, and welcome here. My name is Stanislav and I'm working on the position Software Development Director at Innovecs. Together with me, my teammate Dima, who is working on the position of Senior Software Engineer. Together we are working in the game development, and today we would like to share with you our experience of full stack game development with Unity and .NET. So what is actual full stack game development? First of all, it is a common practice in many areas like web, mobile, and games as well. But we would like to show our approaches that are based on .NET technology and Unity 3D engine. We will highlight them with diagrams. It will be my theoretical part of this presentation and real code samples from Dima that are based on the simple game prototype with a client, backend, and DevOps part. First of all, let's actually define our meaning of the full stack in the game development. From our point of view, it is when one team of engineers using .NET and Unity can cover all areas of the game development, like front-end, back-end, and DevOps. Okay, moving next. There are many possible solutions to create backend for games, like Java, Python, Node.js, PHP, Perl, .NET, and so on and so forth. Many of us who are working as Unity engineer definitely were working with the backend part. From my personal actual experience, the communication regarding the transmit models between the client developer and backend developer take time. We need to discuss the request response, the actual view of the JSON or wherever other formats that we'll be using between the client and server. And on the client part, we will wait until the feature will be implemented on the backend. But when it is ready, sometimes happen typos in JSON format, missing fields, or you understand that you need additional data from backend. And here we go again. Additional meeting, additional discussing, and additional waiting time. And it's good if your backend mate is not busy with other tasks. Otherwise, you are blocked. So our goal was to reduce any blockers as much as possible. That's why we decided to use .NET as a backend technology. Mainly because it is actually dictated by the Unity 3D engine. And as you may know, if you are working with Unity, the main language is Unity C# and .NET framework. So all Unity engineers are familiar with .NET and can learn server-side technology with a fast onboarding. So what we actually got when we move with Unity? We got the reusing of code between the client and servers, because all transport models can be created with C# and located in some repository. We will cover it a little bit later. We also got a possibility of have a single team to resolve all issues on the front end, back end, and DevOps part. We got simplifying planning. For us, story point make more sense from point of view that everyone understand any part of the project. We can resolve any issues. Any developer can resolve any issues like front-end, back-end, and DevOps. No blockers in case of vacations or sick leave. Every team member is replaceable. Productive communications, no meetings between front-end, back-end, and DevOps, because everyone can talk to himself and everyone happens here in our mind. And fast knowledge sharing and onboarding. Every team member can onboard any new team member. Moving next, project structure. Okay, this is actually common structure of our game project. It contains client repository with Unity 3D project, server or backend repository with .NET project, and actual shared repository with a similar C# code that can be used on the client and on the server simultaneously. Usually, shared repository contains transport model that were mentioned before. But sometimes here can be added any kind of the logical part of the game. For example, validation behaviors. Imagine the case with when we create in some game feature of the card game, when the player is able to edit decks. So we have some rules for this deck, like decks must consist 30 cards and some card with certain ID must be present inside this deck. And we have to create validation. First of all, we must create validation on the client part when the save button has to be blocked if conditions are not passed. And also we have to create the same condition on the backend. When we are creating the API, the decks cannot be saved inside the database if the conditions are not passed. So we just create some C# code for validation, put it into the shared repository, and using the same models and the same transport models, we are using actually the same code for the validation block button, or do not allow user to save the deck if, for example, from the client we got wrong data. Moving next, speak about clouds. Every backend must have virtual or real machine where it will be running. We are working with two popular clouds like AWS and Azure. Both of those clouds have all necessary tools for games development, like databases, virtual machines, auto-scaling, DNS services, analytics, and so on and so forth. A lot of services that can cover all parts of the games development. And all of the services have .NET SDK, so they can be simply added and used inside our backends. And every developer who knows C# can simply use them with, again, the small onboarding. It is really handy and efficient to keep backends in the cloud, because actually we don't care about a lot of parts like internet connection, electricity, and so on and so forth. Okay, moving next for our backend. Let's discuss our backend development process. As we mentioned previously, the backend is a .NET project that is located somewhere in the cloud, inside the repository, GitLab, Bitbucket, GitHub, whatever. The build artifacts of the project located inside the cloud, AWS or Azure, and available for the client via the cloud link usually. It's HTTPS or WebSocket link, whatever, depends on the project. But how the backend actually appears inside the cloud, I mean the CI/CD process. To resolve CI/CD issues, we are using Nuke. Nuke is a tool that allows us to build deployment pipelines using C# and .NET. Yes, we are using .NET for the DevOps too, both on the client and on the server part. It is quite handy and robust. Every Nuke pipeline can be executed from any machine with any operation system like Windows, Mac, Linux that had access to the source code and .NET installed. Pipelines can be executed from the IDE or command line interface. So every team member, developer, engineer, or QA engineer can deploy backend artifacts with a simple command line execution. And the pipeline can also be run from Jenkins, TeamCity, or any other automation tool. And let's move from backend to the client part, how actually the client looks like. Client development process has similar bricks. The source code located somewhere in the cloud, GitHub, GitLab, Bitbucket, whatever. Unity engine, of course, in our full stack game development as a development framework for the client, and Unity build pipeline system. These bricks and these bricks. What actually Unity build pipeline system? It is our custom tool that was created to develop CI/CD pipelines inside Unity with C# and Unity API, of course. Every engineer familiar with Unity can create and support those pipelines. Like Nuke, Unity build pipelines can be executed from IDE, Unity in this case, and CLI, Unity batch mode, to execute it from Jenkins or TeamCity. Batch mode is using like the possibility to actually execute build pipelines and create and deploy build from build servers. A few words about the build pipelines. Actually, it is available via the link. You are welcome to join and use it. We can split Unity build pipelines with pre-build steps, build steps, and post-build steps. Pre-build steps, the steps that are used to perform any operation with Unity project, like bump version, set project defines, assign key store, wherever you need to set up your project, your Unity project before the build. The build step, to create the build artifact itself. Xcode for iOS, APK or app bundle for Android, WebGL for web, PC, anything that can be created with Unity API build tools. And post-build steps, to perform any operation with created artifacts like archive, upload to the store, or to the cloud, in case of WebGL, for example. The possibility to create pipelines inside IDE for the client using Unity build tools, or for the server using Nuke, allow us to test and debug them before using inside automation system. So we are sure that pipelines will be working similar locally and in the cloud, because it is using the same code and the same environment. The code of the pipelines is open source, and again, you are welcome to use it. Okay, and let's move and discuss one of our architectural approach to create games for full stack, like a full stacks. This is one of our architectural approach for real-time turn-based multiplayer game. This approach practically implemented for the tic-tac-toe game and will be demonstrated in the second part of this presentation by Dima. A little bit of context to this scheme. The client is able to communicate with server using a real-time connection. Like a WebSocket or a signaler that was selected for the current case. Under the hood, signaler is also working with WebSocket or long pooling. It depends on some circumstances and not the point of this discussion. So we are using signaler like real-time connection. Also, we are using behavior trees to create game logic on the client and on the server. The goal of this approach is to create actual state of the game that is located on the server, and like understand how to send data to the client. I mean, broadcast to all or direct messages to certain client. For example, changes of the game field must be broadcasted to all players. But amount of the, I suppose, in-game currency that player won at the end of the match has to be sent to this player only. my currency for me and opponent currency for him. This possibility can be reached utilizing the command pattern. Commands can be executed from the hub, signal air hub, when the client wants to perform any kind of the operation, or from the behavior trees. This allows us to build flexible code base and bots, create recovery and the reconnect logic. This is actually the theoretical part of our approach. Now I would like to move to the practical part. And Dima, mate, mic is yours.
Hello everyone. Thank you, Stas, for presentation. And now it's my turn. My name is Dmytro, and I'm a senior software engineer at Innovecs. In general, I have 7 years experience in software engineering, and 3 of them are in game development with the full cycle of development process. Server side, client side, and including CI/CD processes for both of them. Okay, let's kick off. Today I'm going to show you the approach described by Stas in action. Let's take a look at the game developed by this approach. As an example of implementation this approach, we implemented tic-tac-toe game. It's a pretty simple game where we have 9 cells, we have an opponent, and let's check out. After clicking the play, there is a matchmaking process. For 10 seconds, we are trying to find the real player opponent, and after that, if there was not a real player opponent, we start our game with bot. So it's my turn. There is timer for my turn, and now it's opponent turn, and let's try to win. Here is, and yeah, here is game over screen where the result of game and ability to go back to lobby. So let's firstly I'd like to show you the server side implementation, and now we will take a look how it implemented, organized under the hood. So the main part of our game, it's possibly the board, and as Stanislav mentioned before, we use states and behaviors. So let's start from the state. Here is the board state, and it contains the cells states itself. It implemented as we could work with it like with enumeration, and also here are a bunch of methods for checking state, updating state, and getting state details. For example, we could get all cells or some specific cell. So also we have behaviors for our state. For board behaviors, there is pretty simple behavior tree. implemented as an extension method for selecting a random cell. A bit later, I'll show you how we use these extension methods, and let's go further. We use, for communication with the clients, we use signal R, and here is the method for selecting cell. Here we got the request. After we got request from the client, firstly we trying to find the active room. Also here is the validation room status, and then we try to find the active player inside the room. After that, we validate the cell. As you can see, here is a message from the board state, checking availability of cell. And after that, the last part here, we notify clients with updated board state. It means that player selected new cell on the board. Now let's check let's take a look on the room behavior and how it organized. So here is matchmaking, and our main is game loop. So let's check the player behavior, where we are waiting for player tune. So this part, we are waiting. There are two cases of completing this part. The timer has expired, or player selected the cell on the board. And if timer expired, we select the random cell on the board without player. And here is our board behavior tree in action. So we have our board state and just calling the extension method. So let's switch to the client, and we will start here from the board state listener. It's a part where we got the message from the server. So a bit back, here we send full state. It's a simple implementation of command pattern, and for method naming we use shared contracts from our submodel. As you can see, here is a full board state listener, and we use it also on the client side. We use shared contracts, and it decreases the possibility of mistyping in the method naming. And if we decided to change this name, for example, here we decided to change the name, we pushed updates, and after we pull the updates on the client side, we will get the compile error, and we need to update this to use new method name. And in such way, possibility of bugs bound with naming decreased, and we will listen to new method. So on the client we also have board state. It's on the client it similar to server side board state, but with some modifications for Unity. For example, it uses as mono behavior, and it also has a collection of cell states. And here we have our all cell states with state inside, and there is only one method, public method for updating cells, and for example, listener works only with board state, and board state decided which cell would be updated and raise the event on selected. Here is it, and here we have our board cells executor. It's our runner of behavior tree, and this executor subscribes to the board state event, and on this event it's only just calling the behavior tree for updating cell, and behavior tree got the updated cell as a parameter. So let's take a look to our behavior tree, and here is an array of possible cells that we seen before on the game demonstration, and this behavior tree is just running a behavior tree of cell that update the cell in visual part. So yeah, also as Stanislav said, we use we also manage our build and deployment pipelines. We deploy our server and client to the Azure cloud. For example, for server we use Azure App Service, and for the deploying client side as WebGL project we use a storage account. So let's reload it. Now I want to demonstrate to you our build pipelines. On the server we use nuke build, and it implemented with C#. Moment, here is our server. Now I want to show you our build plan firstly, and we will check it together. So just type in nuke with parameter plan, we will generate this plan, and that's all our deployment slots stages in our pipeline. So firstly we use here basic .NET platform commands for cleaning solution, building solution, and restoring NuGet packages. Also here our custom action for updating server version, and after that we archive our build and then publishing it to the Azure with deploy target. So now let's take a look how it looks like. So it's simple nuke build pipeline, and it's our configuration for where we have name of our source group, our subscription, and application name, app service name on the Azure. And that's all plans. First it's our clean, restore that runs after clean. Then we build project and pack it to the archive, and after that we deploy it to the Azure. Firstly, we stop our web application deployment, deploy zip, archive, and start web application. So we just we work here with Azure CLI, and in such way we could deploy it. So let's deploy it together. Here is our controller, status controller for getting details of our deployment. Here is environment and deployed version. And now I'll show you how we deploy it. As you can see, Nuke shows for us our pipelines and our build steps, and we could use you could install Nuke global tool to have possibility to work with Nuke with this keyword. If you also could work with Nuke without this global tool, and for this aim you need to work with build sh file script, and it's just for our comfort. So let's try to deploy. Firstly, we say Nuke and we say deploy and run. Now we will see our stages. So Nuke started, our clean, restore, bumped version. After that, when I refresh the page on browser, we will see new version. So 1 second. So our deployment successful. In a second we will get the result of our deployment. And now we can try to refresh the page. So now version is 20, and after refreshing we will get the version of 21. So our version updated, so it means our deployment was successful. And now I want to show you how our client build pipeline looks like. For this, for client pipelines, we use our custom build pipelines developed with C#, and Stanislav mentioned about it. So let's take a look on it. So it contains our pre-build steps, where we build our addressables, updating the version of the client also, and build our game as WebGL build. After successful build, here is also post-build steps. You could add here more than one steps. For example, in our case, we have here uploading our WebGL build to the Azure storage account, but also you could add, for example, unit integrational tests running or checking build status or so on. So now I want to demonstrate you our plan, and deployment of client. So let's open the console, and there are two options how we could run our build pipeline. One of them is we could run it with Unity editor, and also we could run our pipelines with CLI. For this, we close the Unity, and we could run with CLI, and Unity build would be created in batch mode, and we even don't need editor for deploying. Just for demonstration, I run this pipeline with Unity editor. So you could see here appears folder builds. Now we compiling our project, and if I click to build, here's WebGL folder, our new version, and the build itself. Now it's completing our build. 1 second. While it building, so our build system also updates the version, and here is the result of our build. So now post build step, uploading to the WebGL or to the Azure storage. Here is versions of our file. So our build uploaded, and now if we check our Azure storage, let's refresh the page. So you could see here our latest version of client, and if we need to roll back the version of client, we just rename this version to current and remove this directory. And for example, if we need to roll back to this version, we rename to the current and delete this directory. So let's so that's all for my part, and as you could see, it's pretty easy to manage our states on the server. It divided to the separate parts, and we could use it in with responsibility of each of state, and each state also has its behavior. So and also states encapsulates in inside itself additional states, for example, as state cell state inside the board state. Thank you for your attention, and I hope it was useful for you, and came back with your feedback of this approach. And thank you, everyone. Bye.